Imagine waking up to headlines claiming that a Harvard astrophysicist has just suggested a comet streaking across our sky might not be a comet at all, but alien technology. Not speculation from the fringes, not rumor, but a cautious statement from one of the most respected minds in astrophysics. And before the shock even settles, another revelation surfaces. Instruments have detected 9 smaller bodies trailing in its wake, moving with it through the void like a convoy. For scientists who have spent their lives mapping predictable orbits and familiar chemistry, this is the cosmic equivalent of finding footprints where none should exist. For the very first data points, 3I Atlas refused to behave. Its speed, its trajectory, its brightness, all wrong. It was moving too fast to have been born here, following a path that no gravitational hand in our solar system could control. In less than a decade, we've gone from 0 interstellar visitors to 3. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. Each one has challenged us in a different way, rewritten a different chapter in the textbook. Oumuamua, a tumbling cigar-shaped rock that showed no tail, no coma, and yet seemed to accelerate as if pushed by invisible hands. A comet that looked familiar but was steeped in carbon monoxide, proof that it was forged around a colder, dimmer Sunday. And now Atlas, a strange synthesis of the two, a body that looks comet-like at first glance, but grows more alien the closer we look. The green light that made Atlas famous should have been simple to explain. Comets glow green because of diatomic carbon-C, 2 molecules excited by ultraviolet sunlight, but the spectral lines betrayed us. The expected C2 signature was weak, almost non-existent. Something else was painting this traveler in its eerie emerald light, something not listed in any of our catalogs. Under the shadow of the September lunar eclipse, Atlas burned bright and green against the void, glowing more vividly than physics should allow at that distance. Some say faint C2 lies beneath the noise floor of our instruments. Others suspect that carbon dioxide, the dominant gas in Atlas's coma, might be interacting in ways we've never modeled. Either way, our chemistry, our expectations are outmatched. And that becomes the pattern. Every layer of analysis, composition, light, motion unfolds into contradiction. In our solar system, comets live and die by water ice. The sun warms them, they vent vapor, and the escaping gases push dust outward to form the tail. But Atlas runs on a different engine. Its emissions are dominated by carbon dioxide, with water playing only a minor role. That imbalance is not an accident, it's a birthmark. CO2 freezes at colder temperatures than water, which means Atlas likely formed in a star system far older and dimmer than our own. In that sense, it is not just a curiosity, it is a sample return mission from another sun, a fragment of a world whose chemistry tells a story we've never heard before. Even the light reflected off its dust refuses to conform. When sunlight scatters off comet grains, it normally polarizes in predictable ways. But Atlas defies that too, producing what we call extreme negative polarization, an optical inversion that implies its grains are fragile, porous, maybe even fractal in structure. It's as though the particles are whispering in an accent not of our solar system, but of another, one that speaks the language of deep, cold, and unearthly light. Then there is the silence of motion, the missing push. Every active comet shows tiny accelerations caused by jets of escaping gas. These outgassing events act like thrusters, nudging the comet slightly off its predicted orbit, but not Atlas. Despite its furious activity, its course remains perfect, obedient to gravity alone. The options this leaves us are few, and each is unsettling. Either Atlas is enormous, so massive that its jets cannot shift it, or its surface vents are distributed with impossible symmetry, canceling one another's forces. One explanation speaks of a mountain adrift between the stars. The other whispers of intention. But the truth hides behind the glare of its coma. Even Hubble, our sharpest eye, can only guess at the nucleus, perhaps 5 or 6 kilometers across, perhaps much smaller, perhaps far larger. Some argue that Atlas's steadiness proves its size. Others say that the balance of its jets is too perfect to be random. Both positions fracture the boundaries of what we've seen before. Meanwhile, its appearance refuses to hold still. The tail stretches and curls, shifts from fan to spear, ripples like a flag in solar wind. In long exposure photographs, faint bands of color ripple across the coma, iridescent veils that shimmer as Atlas rotates. Radiation pressure, rotation, outgassing, these are known forces. Yet in Atlas, they behave with unnatural precision, like the rhythm of something alive. Then, the whisper that changed everything. The convoy. 9 smaller objects, faint and elusive, trailing in Atlas's path. At first, they were dismissed as data noise, artifacts of processing. But over weeks, the signals persisted. They shared its vector, its velocity, its rhythm through space. Too many, too organized, to dismiss as coincidence. The conservative answer is fragmentation, Atlas shedding pieces of itself under solar heat. But the fragments move with uncanny coherence, as though following a leader. It could be coincidence or choreography. Strip away the headlines, and what remains is still staggering. We are watching matter born around another star sweep through our solar system in real time. A rock, a mountain, a mystery, carrying within it the chemistry and history of a system billions of years older than our own. In a single decade, 3 such visitors have crossed our path. That's not luck. That's the universe reminding us that we've only just begun to notice. As October 29 approaches, Atlas races toward perihelion, its closest and most perilous, passed by the Sunday. This is the crescendo, the moment when heat will strip away pretense and show us what it truly is. Will it flare like a comet, fracture, fade into dust? Or will it hold together steady, deliberate, a thing built for endurance? And what of those smaller bodies behind it? If they're fragments, we'll know soon enough. If they aren't, if their paths remain ordered after the sun's test, then we may find ourselves staring at something unprecedented. Perhaps this is all coincidence. Perhaps we are simply better observers now, catching what generations before us missed. Or perhaps there's something more, an architecture to the void, a galactic current along which objects like Atlas drift from system to system, carrying information, seeding curiosity, testing civilizations that dare to look up. Because if Atlas brightens, fractures, and fades, we will file it away as a strange but natural visitor. But if it alters its course, even by a hair's breadth, if it does anything that suggests control, then this unassuming green wanderer will shatter the boundary between the known and the possible. And yet, even before that verdict arrives, Atlas has already done something monumental. It has forced us to confront our arrogance, the assumption that the space between stars is empty, that nothing watches us as we watch the skies. It has reminded us that the unknown is not a void, but an invitation. So we wait, we measure, we argue, we wonder. Because 3i Atlas is not just a comet, it's a mirror. In its glowing, unblinking eye, we see the reflection of our species, reaching for understanding, yet trembling before its own imagination. The countdown to perihelion is not just a timer on a cosmic encounter. It's a measure of who we are when the universe finally answers back.